messed up 2 or 3 times today, so I don't trust it today. All right, let's do a little bit of work. Find the missing angle. So you got an angle that's 24, angle that's 37. You gotta find that third one. So add those two up, subtract from 180. How much is it? 119. Good job. Change colors. 119 degrees. Number 2 uses the exterior angle theorem. So angle 1 is going to be the sum of those two. So it's just a straight addition. How much? 128, yeah. Number 3 uses a little bit of subtraction in the exterior angle theorem. So if angle 1 and the angle at 79 degrees, they should add up to be 104. So we're just going to take 104 minus 79, 25. Really cakey stuff here. All right, number 4 gets a little bit more intense angle stuff here. So we got to find 3 different angles in this picture. We're given 2 of the angles in this smaller triangle, so those should add up to be 180 with angle 1. So 66 plus 84 is how much? 150. So angle 1 would be 30. And how can we get angles 2 and 3? That's the tricky part. Yeah, 84 and 3 would be a linear pair. We could use that if we wanted to find angle 3. That's one way to go there. So 180 minus 84 would be 96. Which is how much? 41. An alternative way to get angle 2 would be take 84 minus 43, because 84 is the exterior angle to this other triangle here. So you could use that exterior angle theorem as well. All of those ways work. The beautiful thing about triangles, it's kind of like the parallel lines thing. You can go around different ways and get the measures of those angles. And, some of them are more direct than others. All right, number 5, another nice little problem. We're going to try to find all of those missing angles, 1, 2, and 3. How? All right, so that's a right angle, so we know that's 90 plus 43. Subtract it from 180, and you get 47, you said? How could I get angle 2? It's a linear pair with 43. That's one way to get it. Subtract that from 180, you get 137. I could also do 43 plus 47, or excuse me, 47 plus 90 is 137. That's where the exterior angles theorem could be used there. Now let's get angle 3, last one. And you get 31 is final answer. Good job. A lot of different ways to get those angle measurements in here. Linear pairs are still an option. If we get into a picture like on number 6, we get some other things happening here. What do we know the measure of angle 2 is without doing any calculation? Why? They're vertical angles. Yeah, vertical angles are always congruent. We know that. So that helps us out a little bit. And then from there, we should be able to get angles 1 and 3 pretty easily. So how much for angle 1 or 3? 3. Angle 1 is 51. Same rule, 61 plus 68, subtract from 180. Easy stuff today. Number 7, BC bisects angle ACD. And then they want us to find 4 angles in this picture. Say that again. Which one? How? Yeah, 2 and 3 should be 45 apiece, right? Because the angle bisector cuts it in. So 2 and 3 should be 45 apiece. And then we can use lots of different ways to get there. Angle 1 should be how much? 87, 45, and 48. Subtract from 180. Would be 87. That's right. How much? 52. Yeah. A lot of different ways to get there. You could use exterior angle theorem. You could use adding the B 180 out of that. The key was the bisector that cuts it in half. Getting there. All right. Number 8 gives us one of the angles that's not even in a triangle. That angle 2 is not even inside of a triangle. So that could pose a problem. Let's see if we can figure it out. What do we know? How much? How? Tell us how you got there. That's right. Yeah, good job. Yeah, good job. How do you get 26? 64 from 90 is, yeah, good job. So they said angle 2 you can get, because we know this is 90 degrees, so 1 and 2 together ought to be 90 degrees, right? Because that's got to be 180 because it's on the straight line. So we get that. Say it again. Yeah. The explanation they used was that angle 1 and 2 should add to be 90 degrees because the angle that's on their backside is 90 degrees, right? And they make a straight line out of that. So you could add those. We knew angle 1 was 64 through the triangle sum theorem, and then subtract that from 90 is how they got 26. And they knew that would be 90 because the other side was 90. That's probably the best way to get that one. Pretty nice. Ooh, number 9 has parallel lines in it. Excited to use things we should know from the past. Everybody knows everything about parallel lines, right? All right. Well, let's see if we can figure some stuff out. We got 5 angles to find in this one. All right. Let's do some covering up here. If I cover up this line right here and have the only transversal be this one, what do we have? Because they're what kind? Alternate interiors. Good job. So angle 1 should be 73. What are they called? No, they're not. Angle 2 is created from this other transversal. So we can't do that. There's a different way to get there, though. How? Okay, that's a good way. Braden, how did you get it? So you did the same way? Okay, that absolutely works because we know angle 1 is 73 and the other angle over here on this side right here is 49. We know all 3 of those should add up to be 180. So that creates the They're not the same. Consecutive interiors are supplementary.
So you subtract 180 by 73.
Yeah, and then you get the angle 3 would be 107. And y'all said 58 on angle 2. I remember the math there. All right, so now I think we've kind of exhausted this transversal. So let's go to the other one. Because it's what to the 49 degrees? Alternate interiors, so that we get that for free. Because why? So the angle 49 degrees and angle 5 are consecutive interiors. That's one reason to subtract from 180. But we also know that angle 4 and angle 5 are a what? Linear pair, so you can do the same math involved there. It's not changing anything about the measurement that you find. It's still there, but just a different path to get there. Again, parallel lines open up tons of different options of ways to get there. We're just adding in a triangle in the middle of that picture, which makes this lots of fun. All right, problem number 10. Whew, that's got a lot of triangles. There's 3 triangles inside of a rectangle. Oh, me, what do we do? What do we do? How do you know? Angle 2 is alternate interior to the 52 degrees because we know we have what kind of sides on that rectangle. They're parallel. They don't tell us that, but what do we know that about rectangles, right? And we know that's a rectangle because it has 4 right angles in it. So angle 2 is 52 degrees. Good start. What other angle's also that? 6 is 38. And you said angle 3 is 38. That's right. 180 minus 86 would be 94. Is that what you said? That works. Good reasoning. Got 2 left. How?
You know 6, which is 38. So if you add that plus 86 minus 180, you get 56.
Which would be the measure of angle 5.
And the angle 1, you subtract 90 by 56.
Yeah, that'll work.
You get 36.
Both of those ways, that way is a valid way of getting there. Good job. Not bad at all. Lots of different ways to get there. Linear pairs involved there. I heard that from other folks, and then the triangle sum theorem from other folks. Good job. Out of that, nothing bad at all about that. Number 11, even more fun. This one has a little notation in there. It's easy to overlook. Yeah, we got some parallel lines in there. I heard angle 2 was how much? Why? Vertical. Yeah, vertical angles. 71 degrees there for angle 2.
So angle 1 is 60.
Okay, so 47 plus 71, subtract from 180. Angle 1 is 62 degrees. Good job. It means angle 8 is 62 because they are alternate interiors. What was the other one I heard over here, Jake? 3 and 5 are 109 because they make linear pairs. Is that how you get there? So 109. Which one's 47? Because why?
Because 1 and 8 are both 62.
Okay, that's one way to get there. An easier way would be that they're alternate interior angles. They're automatically congruent to one another. So you don't have to do any math to get there. That's one way of getting there. Why? Okay. So if angle 4 is 35 degrees, what's angle 6? 29 how? Tell me how you got there. That's right. So use the triangle sum theorem there with 42 and 109 taken away from 180 to get angle 6 there. Couldn't do alternate interiors there because it introduces more than one transversal into it. So that's why that wasn't a possibility there with those. Okay. Good job. You guys got those. Do some algebra. You like that better? Solve for x and then find each angle measurement in the picture. Yeah, just add them all up. 9x plus 3 plus 5x minus 2 plus 11x minus 21 equals 180. So that'd be 14x and 11 would be 25x minus 23 plus 3 would be minus 20 equals 180. And then add 20. And x, $2 has 8 quarters. So x is 8. And then we're just going to plug those in to each one of those. So 9x, 9 times 8, 72, plus 3 is 75 for angle E. Angle D is 38. 88 minus 21, 67. Again, how do you check that to make sure it's right? Add all those up. If they don't equal 180, somebody's wrong. All of that. Easy stuff. 13 is the same idea. We're not redoing that. Let's do 14. A little tougher looking picture, right? Say it again, Hayden. Okay, yeah, 18x, because 18x minus 15 is the exterior angle to these two non-adjacent interior angles. That's using that exterior angle theorem out of that. So that'd be 17x minus 10. That's going to be x equals 5. And then it says angle CAB, which is this one up here. Plug that in. 13 times 5, 65 minus 11, 54. And then angle ABC is this one down here. So that's 21. Easiest one. And then ACB. That's one that isn't marked in our picture. ACB is this one right here. You could do that, or you could add the 54 and the 21 and subtract from 180. Either way, they're both the same. Same answer either way. That'd be a good way to check to make sure I got it right. So that'd be 75 from 180 would be 105. And then DCB would be 75, just because we know that the linear pair or the exterior angle theorem gets us that. Okay, let's look at let's see, 15. Same kind of problem. We're not going to do it. I'll sing that. The next little page is just extra practice there. Let's skip down to number 5 on that page. We're going to find the values of x and y. Number 1 through 4 are just the same kind of stuff that we've been doing. Number 5's got a little bit more stuff going on. Find the values of x and y and in the diagram. That's all we got to do. We don't have to find angle measurements here. Just the x and y. Well, that's a little difficult because this triangle, if I add them all together, I'm gonna have two variables in my problem. That's not a no-go.
Those two are vertical angles for the same.
Oh, okay, so this is a vertical angle, so this one we could do with one variable. That's the good start. So 6x minus 2 plus 11x minus 9 plus 72 is equal to 180. 17x minus 11 plus 72 would be plus 61. And then subtract 119, 17, I think 7, because it ends with a 9. So x equals 7. And then how do we get y? Okay, yeah, we could plug into 11x plus or minus 9. So that'd be 77 minus 9 is 68. Yeah, and then add those up. Yeah, so 5y minus 8 plus 68 plus 30 equals 180. So 98 minus 8 is 90. 5y is equal to 90. Y is 18. A little bit more thinking involved in that problem. Out of that. So, but nothing too strenuous there. Let's look at number 7. Let's get to it. Because it's got the parallel lines in it. We tend to get a little sidetracked sometimes when we get the parallel lines. We forget what we can do and what we can't do. Oh, yeah. So it says line L is parallel to line M. So that opens up all this stuff with parallel lines that we studied last year. So if that's happening, they want us to find the measure of x and y out of this problem. So what can I do? Because that creates a triangle, right? All right, there we go. So yeah, so I could take 63 plus 7x minus 31. And then why can you say the plus 5x minus 8? Why do I know that this also goes here? They're alternate interior angles, so that would be definitely a good choice right there. Okay, that's only one transversal that creates the relationship there. So set those up, solve. So that'd be 12x, 32 minus 8, be 24. All right, 12x plus 24 is equal to 180. Subtract 24, 156, be 13 times. Now let's try to get y. Good, because the 5x minus 8 and 4y plus 27 are what kind of angles? Consecutive interiors. So that means they add up to be 180. So I know what x is 13. So 5 times 13 minus 8. That'd be 65. 57. All right, so then I'm setting up 4y plus 27 plus 57 equals 180. And solve that. So 4y plus 84. And then subtract 96 divide 224. So using all those things with parallel lines, guys, you know this is just like an algebra class. Nothing disappears that we do. We're going to use it again as we go along. So as we build up things, all that stuff comes back to get us. All right, when you look at the next set of problems there, you've got no picture involved, but same concept. Angle P or triangle PQR. They give you the measure of angle P, the measure of angle Q, and the measure of angle R. What are you going to do with all three of those? Add them up, set them equal to 180, right? And then that gets you X, and you use X to find the rest of them. Nothing different about that problem. Number 9 is one of those translation problems. So it's the same stuff. You just got to translate your angle measurements. Then do the same work. Add them up, equal to 180, get X, and then get the angle measurements. Easy stuff. Let's look at 10. This one's a little tougher. It says the measure of angle L is 13 more than the measure of angle K, and the measure of angle J is 7 more than 6 times the measure of angle K. Find the measure of each angle. So for this one, I'm going to draw myself a triangle. It doesn't matter if you draw it equilateral, if you draw it isosceles, or you draw it right. It doesn't matter. You're just drawing a triangle with corners J, K, and L. I think it helps us kind of get what's going on. Measure of angle L is 13 more than the measure of angle K. And then it says the measure of angle J is 7 more than 6 times the measure of angle K. What's everything stemming off of? K. So I'm going to call measure of angle K, that's going to be my X. And then the measure of angle L would be X plus 13, right? And then the measure of angle K, or angle J, 7 more, 6X plus 7, And then you can work it the same old way there. So X plus X is 2X plus 6X is 8X plus 13 and 7 is 20. 8X plus 20 is 180. 8X is equal to 160. X is 20. So we know the measure of angle K is 20 degrees. The measure of angle L would be 33 degrees. And 120 plus 7 is 127 with J. So there, drawing a diagram can help you. You don't have to draw a diagram. I tend to think a lot of times in pictures. You may do the same way. I don't know. So 11 is a similar idea. The measure of angle W is 5 less than twice the measure of angle Y. And then the measure of angle X is 21 more than the measure of angle Y. Everything stems off the measure of angle Y. So you make that X and go from there. So 11 is the same idea as 10 was. 12. Measure. This is the same idea. The measure of angle F should be your X, and you go from there. So y'all got the idea of setting those up. So I don't think we need to spend too much time doing those. Go to that last little bit there. Closer look at isosceles and equilateral triangles. So isosceles triangle, 2 congruent legs. So this is part 25. All right, isosceles and equilateral triangles. 2 congruent sides are called the legs, and then the angles where the legs intersect is called the vertex angle. So in our picture over here, the angle 1 is the vertex angle. The legs are side AB and side BC. Is what's going on there. The side opposite the vertex angle is called the base of the isosceles triangle. The angles at the base are called the base angles. That makes sense, doesn't it? 2 and 3 are the base angles on this particular isosceles triangle that we've got drawn there in that diagram. So some vocabulary that goes along with those that you probably knew most of those anyway. Isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So in our picture, for example, if side AB is congruent to side BC, then angle A is congruent to angle C. That's what that says. Isosceles triangle theorem. The isosceles triangle thing, I'm emphasizing this because we're going to get the proofs later on, not today, but later on this unit we'll get some proofs. Everybody loves those. But you got to know what you're dealing with here. So isosceles triangle theorem says you get two sides congruent, the angles opposite of those sides are congruent as well. So that's what's happening there. The converse of that, what's the converse do? Switches the hypothesis and the conclusion. So it says that if angle A is congruent to angle C, then AB is congruent to BC. And if you can get those things happening, then you know you've got an isosceles triangle that you're dealing with because you got two sides that are the same. And that's the definition of an isosceles triangle. Okay. So those two theorems there will come back up when we get to proofs with this stuff, which will be in a day or two, depending on the snow forecast. Yeah, sure. Why not? I watch it just to get disappointed today. All right, let's look at number one of the practice problems here. Real quick and easy. We know that this is an isosceles triangle with sides JK and KL congruent to one another because of the notation on the picture. So if we know that angle L is 68 degrees, what's angle J? 68, automatic. And then how do we find angle K? Yeah, double the 68, subtract it from 180. That'd be 136 from 180 would be 44. On this one, they give us the vertex angle on number 2. The vertex angle is 106. That means there's how much left to split between C and E? Yeah, subtract that from 180 and then do what with it? Divide it by 2. So that'd be 74 divided by 2, which is 37. Number 3, what's the length of YZ? 12 centimeters, right? How do we find the vertex angle? All right, so 180 minus 154, 26. Stuff. Let's do a little algebra. Y'all love this a little bit more than the rest of life. So, how do we do that? Yeah, just set them equal to each other. 5x plus 9 equals 8x minus 30. So that'd be 3x is equal to negative, or negative 3x is equal to negative 39. X is 13. Yeah. Number 5, do the same way, right? Nothing different. Not doing that. Yep. Go to number 6. What do we do with those? What's the notation? What's the notation in the picture telling us? These two angles are the same, and through the converse of the isosceles triangle theorem, then the sides have to be the same too. So that's through the converse of the isosceles triangle theorem, we can set those equal to each other and solve. That'd be 8x is equal to 24, and 3 is equal to x. Number 7, it's the exact same thing. You're going to do the same work there, so I'm not doing that one either. Triangle RST, if RT is congruent to ST and the measure of angle R is 9x plus 2, the measure of angle S is 13x minus 18, and the measure of angle T is 17x plus 1. Find the value of x and the measure of each angle. All right, so on these, I think it is helpful to draw a picture of what's going on. Triangle RST and RT is congruent to ST. So where is the vertex angle at? At T. So when you draw your isosceles triangle with that, T needs to be up there at the vertex angle. We know that because it is the vertex that's included in both of the congruent sides. And then you could do our work from there. So if we know the measure of angle R is 9x plus 2 and the measure of angle S is 13x minus 18, do I even need anything about the measure of angle T? Is it needed information to find x? Not really. I could find x without having that measure of angle T anywhere in there. So I could set 9x plus 2 equal to 13x minus 18. Because it's an isosceles triangle. By its definition, they're saying that those two sides are congruent. So those two angles had to be congruent. So that's going to be 4x equals 20. X is equal to 5. And then from there, I just plug it in. 5 times 9 is 45 plus 2 is 47. 65 minus 18 be minus 20 would be 45, so 47 again. Oh, those are congruent anyway. And then T, 17 times 5, 86. Number 9, it tells us that angles D and E are congruent to one another. So which one of those is the vertex angle? F. So when you draw that, F is up top. These are congruent to one another. So that means we automatically get those sides being congruent to one another. You set it up, solve it out of that. So the measure of each side could be found once you found X. So DF and EF, 4x minus 8 equals 7x minus 35. 3x, 27. X is 9. And then go from there. You can find the rest of that. No problem there. All right. 10 is the same thing. Let's go on to the equilateral triangles. Try to finish up here. A triangle is equilateral if and only if it is equiangular. So if the measure of angle A equals the measure of angle B equals the measure of angle C, then side AB equals side BC equals side CA. If all the angles are equal to each other, then all the sides got to be equal to each other. The way it works. And then the converse of that, measure of angle A equals the measure of angle B equals the measure of angle C. What do we know about the measure of angle C in number 11? 60. Is that the case for every equilateral triangle?
Yes.
Yes. Every equiangular triangle. Are the angles always 60? Yes, they have to be. The only way that three angles could add up to be 180 and they all be the same would be if they're 60. So the 9
May I
and
have your
9.
attention, please? Don't forget
Out of
we
that.
have the wall stickers for sale for
All right.
$2 in the office.
Let's
Also, any FFA members who have participated in an an activity above the chapter level or plan to participate in the state agriculture fair at the state of Bay Convention will need to be here in the morning at 7:30 for a meeting in Mr. Ledford's room. I need Joey Erdman and Katie Hart to report to the office when the bell rings. Thank you.
All right, there's one of them. Wear a badge and hold a gun.
We get in territory.
Three. Sure. I've got them up here. There's
Also, there's been a class reading that has been turned into the office. If you've lost one, come by the claim.
Guys, the answers are up here. If you want to take pictures of them.